Lesson 1.5, Getting Coordinated, using coordinates to describe transformations. In this lesson, you'll apply transformations to points on a grid if you know their coordinates. Remember that this recording provides a brief overview of the lesson, and it should help students who were absent to understand the main ideas of our in-class exploration and discussion. Before we get started, since we're going to be using coordinates, we should probably remind everybody how to find coordinates or identify coordinates in a coordinate plane. On the right here, I have a coordinate plane. It's really just the intersection of two number lines. We see this blue number line going from left to right that we call the x-axis, and this red number line that goes from bottom to top that we call the y-axis. Where those two number lines intersect is at where each of the number lines is equal to 0, and that's called the origin. To name coordinates like the one we see here in black, we need two numbers. The first number tells us from the origin how far left and right we go, the horizontal distance from the origin. And the second number tells us the vertical distance from the origin, how far up and down we go on that number line. So if we look at this coordinate and we start at the origin, we'll move along the blue number line first, the x-axis, to get our first number. Since we move 3 units to the right, our first number is positive 3. To find the second number, we look at how far up or down we go, the vertical distance from the origin. Since we move up 2 units to be level with that point, the second number is going to be positive 2. If I had a coordinate that was lower than this blue number line, I would still start at the origin, see how far to the right I went for my first number, and in this case, how far down I would move, which would give me a negative number on this red number line. Let's get started with the activity now that we're reminded of how to name coordinates. To get started, we're going to look at a more formal way to name the points that make up the vertices of an image. Here I've got a pre-image with its vertices A, B, C, D, and E. So this shaded pre-image has been reflected to form this image. What you're asked to do first, or what we were asked to do first, is move the point labels to the correct corresponding spots on the image. So I have these 5 coordinates down here, and I'm asked to place them on the correct corner of the image. Well, in the pre-image, the point A is here. So I'm going to guess that this coordinate is going to correspond right there. And you'll notice there's a small difference between this capital A and this capital A. This one has what looks like an apostrophe here, and in math it's called a prime. This indicates that this is going to correspond to this point, but this is a transformation of that coordinate. I refer to this coordinate as A and this coordinate as A prime. Let's go ahead and move these other coordinates. B prime would correspond to B in the pre-image. C prime corresponds to C in the pre-image. D prime in the image corresponds to D in the pre-image, and E prime in the image corresponds to E in the pre-image. For the next few slides, we're going to look at a transformation in 2 different ways. We're going to have a reflection here. We're asked to drag the points to make the image of the red triangle after a reflection across line K. So here's our mirror, and we're going to try to find the image from this pre-image by dragging these points. Okay, so the mirror image of this coordinate, I'm going to say would be right about here. The mirror image of this coordinate, I think would be like right about here. And the mirror image of this one is kind of difficult. Looks like it might be right about there. Okay, and it'll draw that triangle for me. Not too bad. And we're going to try it again, this time with a coordinate plane. This is the same triangle, and I'm asked to drag the points to make the image of the red triangle after it's reflected across the y-axis. So Here's our y-axis. It's labeled here. And it's really the same as we did before. But I think this is going to be a lot easier. As I'm moving this coordinate and mirroring it, I can tell exactly how far I'm going. That would have been helpful. As I'm taking this coordinate, it looks like it's, well, 7 units from my line of reflection. So I'm just going to move it 7 units to the other side. And I'm going to reflect this coordinate that's 4 units from my line of reflection and move it 4 units to the other side. All right, and there we go. So did the coordinates help? Heck yeah, they did. Now, I'm going to be honest, I was pretty proud of how well my image turned out when I didn't have coordinates. But if you were to do this on your own, the first time I did it, it was pretty wonky. I noticed that when I had coordinates, I was able to make a much more precise image from this pre-image. So coordinates are really helpful in transformations. We're going to explore a little bit with the 3 different transformations we've talked. We'll start with reflections. And we're going to write a rule for reflections. Let's look at reflecting a single point across the y-axis. Remember, here's our y-axis. It's this vertical line. Let's move the red point around and observe what happens to the coordinates of both points. I'm just going to move my red one here. And I notice that the coordinates are 6, 5 in my pre-image and -6, 5 in my image. Let me see what happens when I move it a little more. Now I notice that in my pre-image, the coordinate 7, 1 changes to -7, 1. So the 2 numbers are the same, except the first number, the x value, is opposite. Move it a little bit more, see what happens. Yep, that first number in each coordinate is opposite. The second number in each coordinate is the same. So if I know the coordinates of the pre-image, the red one, back here, I can find the coordinates of the black image by saying that the first number, that's the x value, is opposite, and the second number, that's the y value, is the same. So when I reflect it across the y-axis, that's what I notice. So let's go ahead and try this out. We're going to reflect the triangle across the y-axis. And our rule from that we just wrote was that the first number is going to change to the opposite, and the second number is going to stay the same. So the first number in A is going to change from -2 to +2. The second number is going to stay the same. So -2 to +2, and the second number stays the same. Let's do it with B. So this will become -7 and +1. There it is. And you'll notice the little apostrophe, the prime mark, when it's marking the image. And here, I'm going to reflect it across the y-axis. My first number is going to change to the opposite. The second number will remain the same. -4, -5. So that should work. I've moved A prime, B prime, and C prime. And there is my triangle. Looks great. All right, let's look at translations. It's not going to be quite so obvious what the pattern is, but let's try it out. We're going to move that red point around and observe what happens to the coordinates of both points. All right, so the red point is my pre-image, my black point is the image. Just scooch them around a little bit. And what I'm noticing as I move from left to right is that when this red number decreases by 1, the black number decreases by 1 as well. So they're moving the same. So when I move left and right, those red numbers change. And I also notice that the red number is always 4 more than the black number. So 6 is 4 more than 2. 7 is 4 more than 3. And What do I notice about this second number, the y value? I have 5 and 2. 5 and 2. Let's see, move it up and down. 7 and 4. 1 and -2. It looks like these are always 3 apart. So this number is always 3 more than this number. So if I know the coordinates of the pre-image, I can find the coordinates of the black image by, well, I'll take the first number, the x value, and subtract 4. X value is the first number. And I'm going to subtract 3 from the y value. And in this case, with this translation, that rule should work no matter what the coordinate is. So let's apply that translation to this triangle. Here's my rule. I subtract 4 from the x value and 3 from the y value. I'm going to start with this coordinate. I'm going to subtract 4 from this value. That'll give me 0. And I'm going to subtract 3 from this value. That'll give me 2. 0, 2. I'm going to do the same with this coordinate. Subtract 4 from this and 3 from this. That'll give me -4, 2. Oops. -4, 2. And one more time. I'll subtract 4 from the first number. That'll give me 0. And I'll subtract 3 from -1. That'll give me -4. So when I subtracted 4 from all of the x values, and I subtracted 3 from all of the y values, I translated the figure. Let's look at our last kind of transformation. We'll look at a rotation and write a rule. We're going to look at a 90-degree counterclockwise rotation around 0, 0. So imagine that 0, 0, the origin, is like the center of a clock, and this point sits on one of the hands. To move it counterclockwise, I would be moving it in this direction, which would be opposite the direction that the hands of a clock would move. So we're going to move the red point around and observe what happens to the coordinates of both points. Let's move it here. If I compare the pre-image coordinates with the image coordinates, the numbers are kind of similar, but they're flopped around a little bit. I can see that this x value from the pre-image becomes the y value in the image, and the y value from the pre-image becomes the x value and changes to its opposite. Let me try it somewhere else. I see the same thing here. In the pre-image, the x value becomes the y value in the image, and the y value from the pre-image becomes the x value in the image and switches to the opposite number, from 6 to -6. Let's look at one more. I'll move it down here. Again, if we look at these numbers, 6, -3, and +3, 6, I see that the x value becomes the y value, and the y value from the pre-image becomes the x value, but it switches from negative to positive, switches to its opposite. So let's see if we can put that into words. If I know the coordinates of the pre-image, I can find the coordinates of the image, a 90-degree counterclockwise rotation, by switching the x and y values and making the, how can I say this, the x value of the image opposite of what it was in the pre-image. All right, so there's my rule, and I'm going to use that in this next slide to apply this rotation. I did this a little bit earlier, so I'm going to reset it. Okay. We can move these around a little bit. So for this first coordinate, I'm going to switch x and y. That's what it says. Switch x and y, and then make the x value of the image opposite. So I'll change from 1, -7 to -7, 1. But I will change, let's see, I'll change the -7 to a +7. So +7, 1. It's easier when I write this down. For our second coordinate, I'm switching x and y. So instead of 1, -2, I'll have -2, 1. But I'll change that -2 to positive. So I'll have +2, +1. I think I labeled these wrong. There we go. I think that's right. Yep. And for C, I'll switch these two from 5, -2 to -2, 5. But I'll change that -2 to a +2. So I have +2, 5. I feel like I did something wrong here. Oh, you know what? I didn't scooch this one over quite enough. Okay, so let's see if that worked. And it sure did. So we were just looking for patterns and applying those patterns over and over. So we're going to pick a new transformation and then move the red point around. And if I know the coordinates of the pre-image, I can find the coordinates of the black under the transformation that I chose. So let's do a rotation of 180 degrees where the center is 0, 0. So 180 degrees would be like going halfway around the clock. And as I'm looking at these two coordinates, I see that the numbers are exact opposites. So 7 becomes -7, 5 becomes -5. Remember, this is a different rotation than the one we were working with earlier. This one's 180 degrees. So I could write a rule for that. The x and y values are switched to their opposites from the pre-image to the image. If I wanted to do a reflection across the x-axis, I could say that the x values stay the same and the y values become the opposites. And if I wanted to look at a pattern for translating 3 units to the right and 5 units up, as I'm comparing these two coordinates, looks like 3 units to the right means I'm going to be adding 3, and 5 units up means I'm going to be adding 5 to the y value. So in all of these, the x value, if I add 3, gives me the x value of the image. And the y value from the pre-image, if I add 5, I get the y value from the image. So I add 3 to the x value of the image and add 5 to the y value of the image. Sorry about that. I'm going to change that to pre-image. Sorry if that confused you for a second, but I fixed it. So if I can use coordinates and write specific rules that I can apply to anything in the figure. So to cool down, the pre-image, the shaded one, is reflected across the x-axis to create the image, the unshaded one. So if I want to enter the missing coordinates, well, I don't quite remember what they were, but I can probably piece it together. If this is the coordinate 3, 1, then these coordinates, I'm still moving to the right 3, and I bet this is down 1. So 3, -1. So I can apply that same pattern to all the other coordinates here. The x values are going to stay the same. The y values are going to change to their opposites. Let's do this coordinate from the pre-image and its corresponding coordinate in the image. The x value stays the same, that's 4. The y value is going to change from 3 to -3. In the pre-image, I have the coordinate 2, 5. Like all the other points, the x value is going to stay the same, and the y value is going to change to its opposite. This was kind of a long lesson, but in this lesson we applied transformations to a polygon on a grid. And if we know the coordinates of the vertices, we can notice some patterns and use those patterns to and apply them to all of the coordinates on the vertices instead of just one.